Hello, welcome to Tennessee's at-home learning series for math. Today's lessons for all our sixth graders out there. All children are welcome to tune in. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee Schools, and I'm so excited to be your teacher for today's lesson. Welcome to my virtual classroom. If you didn't see any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can tune into today's lesson, though it may be more fun to go back and see previous lessons since we may be talking about things previously learned today. So today, we'll be learning about the area of parallelograms. Before we get started, to participate fully in our lesson today, you'll need to follow pencil and paper and the calculator if you have one. Y'all ready? Let's begin. All right, so I want you to draw a rectangle on your paper. Don't worry, it may not be perfect. All right, so here are some sample answers. So you might have drew your rectangle like this. Remember, it doesn't have to be perfect. Or you might have drew your rectangle like this. Or you might have drew your rectangle like this. These are all excellent ways. So, what do you remember about the parts of a rectangle? Yes, you do remember. Some of you mentioned that the opposite sides are parallel. Others of you said that it has 4 right angles, which is good. I also heard someone say that the opposite sides are equal. All of these pieces of information are correct and allow us to fully work with rectangles. I'm going to give you a rectangle. I want you to use what you remember about finding the area. You can use a calculator if you need it. We will discuss and see how you did. Y'all ready? Here's your rectangle. All right, so I see that several of you remember that A equals length times width for the area of a rectangle. You have used that for a few years, and I know that it's familiar. Let's check your calculations in finding the area of the given rectangle. So again, we have area equals length times width. What is our length? Correct. I'm going to use my length as 1 centimeters times since 1.85 centimeters times 2.20 centimeters equals what? Correct. And we got to make sure that we put our units. So area of this rectangle is 4.07 centimeters squared. Again, don't forget those units. So how did you do? Great. The area of the figure is the measure of the number of units squared needed to cover it without any gaps or overlaps. We're going to build on that knowledge to move you into special quadrilaterals today. So we are going to work together today to determine how we can use the method for finding the area of a rectangle to find the area of a parallelogram. Y'all ready? Let's get started. So I want you to look at this problem. The problem reads, Victoria is making a quilt. She is using material in the shape of parallelograms to form the pattern. The base of each parallelogram can measure 9 centimeters and the height measures 4 centimeters. What is the area of each parallelogram? So we need to first determine what shape we are working with on this quilt. We will use the grid paper to help us visualize the pattern. The shape used for the quilt is what? That's right, the shape of the quilt is using a parallelogram. What are similarities and differences that you see between a parallelogram and a rectangle? Good noticing. They do both have four sides, which means they are both quadrilaterals. And yes, they both have base. Someone else mentioned that the opposite sides are parallel. I also heard someone say that they are different due to the fact that a parallelogram does not have four right angles like a rectangle does. And that's a great observation. All of these are correct. By definition, a parallelogram is a quadrilateral and it has four sides with two pairs of parallel lines. Let's look at how we can use what we know to find the area. So here's my question. Is it possible to compose a rectangle by rearranging the pieces of a decomposed parallelogram? Remember, to compose is putting figures together. When decomposing is breaking figures apart. So knowing that, if we were to cut along this dashed line, and remove this triangle, let's see what happens. I'm going to take it, I'm going to cut here, remove my triangle. And so now I'm going to move my triangle from here to the other side. I want to know what just happened. So we see that the parallelogram can be cut along the height, which is where I just cut, and put back together to form a rectangle. We can restate this as the parallelogram can be decomposed and moved around to compose a rectangle. So now knowing this, now my base is 9, my height is 4. What is the area of the rectangle? Good, somebody said the area is 36 centimeters squared, or square centimeters. Does these two figures contain the same number of unit squares? Yes, we can see that the base of the original parallelogram is now the length of the rectangle, 9 centimeters. We can also see that the height of the parallelogram is now the width of the rectangle, 4 centimeters. This allows us to see and know that the area of the parallelogram is equal to the area of the rectangle. What is the area of the parallelogram? Correct. Finding the area of the parallelogram is also doing the base times the height, which still gives us 36 centimeters squared. Good job. Let's try another one. I want you to compose the given parallelogram into a rectangle to find the area. So what is the problem asking us to do? Correct. We're asked to take the given parallelogram and compose it into a rectangle to find the area. What did we just see that we could do in the first example? Correct. We saw that we can cut along the height of our parallelogram to form our rectangle. So let's try doing that with this one. So I know if I were to cut along here, I can compose it here to make our rectangle. So I'm going to redraw a rectangle. And now doing that, I know that the base is 5.5 yards, and I know the height is 2 yards. So now can we find this area? Yes, the area of the rectangle is the product of the length and the width. So area, the product of the length and the width. So I know my length is 2, my width is 5. When I multiply those together, 5.5. When I multiply those together, I'm going to get what? Well, let's dive in. So remember, one way to multiply a mixed number is to use the distributive property. This allows us to operate with numbers in an easier way. So I can take and use the distributive property. to now multiply. I know that I can multiply 2 times 5 plus 2 times 1/2. 2 times 5 is going to give me 10. 2 times 1/2 is going to give me 1. So the area of this is 11. 11 what? Correct. Yards squared. I could also do this another way. I can also do this by turning my mixed number into an improper fraction. So, what is 5.5 as an improper fraction? 11 halves. So knowing that, I can now multiply. I don't know if you remember, to multiply this, I can write that 2 over 1 to make my fraction. So that'd be 2 over 1 times 11 over 2. That's 2 times 11, which is going to give me 22. 2 times 1 is going to give me 2. And then that will also give me 11 over 1, or 11 yards squared. Good job. So now we know that this tells us that the area of the parallelogram is 11 yards squared. We will use this information to continue working with special quadrilaterals with parallelograms. What did we just determine the formula for the area of a parallelogram to be? Yes, the formula is area equals base times height, where the B is the base of the parallelogram and the H is the height of the parallelogram. So here's our first problem. I want to find the area of the given figure. So what is the given figure? Correct, it's a parallelogram. From our previous problems, we also know that we can compose this into a rectangle. I can cut along my height to move my triangle to compose this now into a rectangle. So now I'm going to redraw this into the composed rectangle. So now we can find the area of the rectangle. So now to do that, we're going to do the area times 2.1 times 6.3. When I multiply these, that's going to give me an area of what? Don't forget, you can use your calculator if you have one. 13.23 meters squared. So let's move into using the formula we discovered for the area of a parallelogram. What was the formula of the area of a parallelogram? Area equals base times height. So in this figure, what is our base? We know our base is 6.3. What is our height? Correct. We know our height is 2.1 meters. So knowing this information, I can start substituting. I can go in and I can substitute 6.3 with 2.1. When I get the solve this, I can get the product of this, and that's going to give me an area of, you got it, 13.23 meters squared. Oh, you guys are doing a good job. And I hope you're starting to see the connection of using the formula for the rectangle and the formula for a parallelogram. Let's try another one. So here's our next problem. So using what you learned today, I want you to find the area of the parallelogram in two different ways. How have we found the area in previous problems? Correct. One way we did this is we composed the figure into a rectangle, and we used the area formula. Take a moment to compose the figure into a rectangle. So I can cut along the height, move my triangle over. So what is my base? 15. Good job. What is my height? Ooh, this is tricky. I have two numbers to choose from. I can either choose 13 inches or 12 inches. So how can we identify which one of these is the height of this from this given parallelogram? Correct. The height of a parallelogram forms a right angle at the base. So that means my height has to be what? 12 inches. Good job. So we do not need the side length of 13 inches to find the area. So when might we need the side length? I agree. We might need the side length if we were finding the perimeter of the figure, but we're not right now. We're looking for the area. So now let's find the area using the composed rectangle. What is the area of this rectangle? So the area of my rectangle, length times width, area equals 15 times 12. And that's going to give me an area of 180 inches squared. Good job. So what's another way we can solve this? Correct. We can use the formula of finding the area of a parallelogram. And we know that is area equals base times height. So the base of my parallelogram was 15. The height of my parallelogram is 12. When I multiply the two of those together, that's going to give me an area of 180 inches squared. So using two different ways, we confirmed that the area of a given parallelogram is 180 inches squared. Good job. You've done great working with parallelograms today. I want to show you one other way we can use the area formula to help us solve for parts of the parallelogram. You ready? All right, so in this example, a parallelogram has an area of 98 square feet and a base of 14 feet. What is the height of the parallelogram? So what are we given? Correct, we're given the area in the base. So we know that the area is 98 square feet or feet squared, and we know that the base is 14 feet. Now, what is the problem asking for? Good, it is asking for the height. So I know that I'm looking for my height. So let's draw a figure with this given information. So let's draw a parallelogram. Remember, it doesn't have to be perfect. So I know that my base is 14 feet. I know that my area is 98 feet squared. And I know that I'm looking for my height. Does yours look similar to mine? Okay, so if you know the area and the height of the parallelogram, how can we calculate the base? All right, so our formula is area equals base times height. So now I can start substituting what I know. I know my area is 98 feet squared. I know my base is 14, and I'm looking for my height, which is my h. So using the division property of equality, I can solve this equation. Divide by 14 from both sides. That leaves me with h. 98 divided by 14 is going to give me 7. So this is giving me a height of 7 what? Feet. Good job. So let's look at another one. So I want to find the unknown measurement for the parallelogram. So take a moment to determine what information we are given and what we need to find. So what are we given? Correct. We're given the area of the parallelogram. What else are we given? Correct. We're given the base. I'm going to go ahead and label this my base. So now what are we looking for? What is our unknown? Our height again. So we're going to solve for our height. So let's get started. We can use a relationship between area, base, and height to find our height. So again, for our parallelogram, to find the areas, area equals base times height. We can start substituting what we know. I can substitute my area for 11 yards, my base for 5.5, and I know I'm looking for my height. And now we're going to divide by both sides. So before I start dividing, I can rewrite my mixed number into an improper fraction, which is going to be 11 halves h. Now I'm going to divide. That's going to leave me with h. It's 11 divided by 11.5. So now I'm going back to previous lessons. I know I can write this as 11 over 1. And now I want to use multiplication to help me get this. What do I have to do with this fraction? Do y'all remember that term? Correct. I take the reciprocal. So 11 over 1 times 2 over 11. So now I can start multiplying. 11 times 2 is 22 for my numerator. 1 times 11 is 11. So that's going to give me a height of 2. But 2 what? Correct. 2 yards. Good job. As we pull our learning for today together, we will see a common thread of understanding. We see that we can find the area of a parallelogram by using the relationship between rectangles and parallelograms. All right, so to make sure that you understand how to find the area of a parallelogram, let's do a few more together. So here's our figure. We want to find the area of this. So I want you to take a moment to redraw this figure so it is composed into a rectangle. Good. After you've cut along the height, your figure should look like this. So now we can find the area of our rectangle. What is the area of this rectangle? 8.3 times 1.2. The area of this rectangle is going to be 9.96 meters squared. Remember, the area of a rectangle is length times width. So now I can do the same thing using the area of a parallelogram to confirm. So the area of my parallelogram is area equals base times height. I know my base is 8.3. I know my height is 1.2. That gives me an area of 9.96 meters squared. Good job. Let's work another problem together. I'm going to let you work this one, and then we'll go over it. So here's our example. This says find the area by taking the given figure and composing it into a rectangle. All right, so what did you get when you solved this problem? Let's check your work. When we compose this into a rectangle, your rectangle should have looked like this. So now let's use the formula of a rectangle, which is area equals length times width. That's going to be 3/4 times 2/3. When I multiply those together, that's going to give me 1/2 feet squared as my answer. Good job, y'all. Great work. Today we reviewed finding the area of parallelograms. I hope you're seeing some connections to the area of a rectangle. You sure did do a great job. I'm so excited to be here today. After the video, you have some problems to practice on your own. You can find those independent practice problems on the www.tn.education website, and I will show you them here shortly. Great luck. Thank you for hanging with me today. I enjoyed reviewing the area of parallelogram with you. Thank you for inviting me into your home. I look forward to seeing you in our next lesson at Tennessee's At Home Learning Series. Goodbye.